Hi Dorothy. Alright, so this question, right, what happened is that it's a bit, you have to apply a bit of the idea of collinear and also the idea of parallel. So if you remember, right, I told you that if let's say we have two lines that are parallel, right, they are parallel. Let's say I have two lines. I have two lines that are parallel. Okay, two lines are parallel. Let's say these two lines A, B are parallel. Okay, if they are parallel, then we are able to write them as, okay, let's say A is here, then this is B, and then we have C, D, right? So if they are parallel, remember I told you that we are able to write this as, I need to just let me open up. Okay. If it's parallel, right, remember I told you we can write as AB equals to lambda of CD if they are parallel, right? Not? And also the same time is that if they are collinear, this is parallel. Okay, remember that we talked about this. This is parallel. Okay, if they are collinear means that they lie in the same straight line. So let's say the 3 points, right, lies on the same straight line. Let's say A, B, and C. A, B, and C on the same straight line. Then, right, we can also say that AB equals to, AB is equivalent to, right, AB is equals to lambda, let's say BC, right, like that, BC. Okay, or it can be AB equals to lambda AC also can, any other combination. But you can see the difference. If it's collinear, right, if it's parallel, right, the relationship that you have, the angle, right, the points, right, will all be the different one. You see A, B, C, D, they're different angle. The moment, right, you see that the both sides have something in common, then this is talking about collinear already. So in this question, we are applying this concept. We have learned this before, right, in our workbook. Okay, so now the question say that, right, the diagrams, the origin is O. A is the midpoint. A is the midpoint of OB, right, and E is the midpoint of AC. So E is the midpoint of A to C. So we know that since this is A, right, we see E is the midpoint. Therefore, here, from here to here, from E to C, right, from E to C, I'm looking at this direction here, from E to C, this direction only, right, is half A. Why? Because A to C, right, is A. But E is the midpoint. So here, right, will be half A. This is half A. 1/2 A. Don't forget a baby, okay, baby. So this is half A. Same thing go for this part here. This is also half A. Because that's the midpoint. AE also gonna give me half A. Okay? Alright? So the first question is simple, right? The question just want to find AB. So I find A to B. So I just take AC plus CB. Remember that the one that we learned. So AB equals to AC, right? AC plus with CD. So AB, right, is equivalent to AC is A. AB is A. And CD, right? CB, not CD, CB. Is equivalent to B. So it's just A plus B. Okay, I think this one is easy. Okay. The reason why I must do the whole question because I need to do that in order for me to answer the next question. So this is that. Okay, right? Okay, next, right, they want to find OE. Okay, how do we do that? OE. There's a problem now. Okay, because I don't know that what is OE. I have no idea. So what can you do for OE? What do you think? Right? So now, we use collinear, right? The idea of collinear to find the OE or OD, okay, or whatever you have here, okay? The question already say that E, right, OE, right, is just the position vector of E, okay, from O to E, right? And the question already say that A is the midpoint of OB, O to B. So once you know that, right, here you know that it's AB already, A to B, right? From the first question here, you know that AB, right, is actually A plus B. So this is A plus B. And then, right, okay. And then, right, this is also midpoint. This is the midpoint of O. The question will say, A is the midpoint of OB. Therefore, right, this is also A plus B. O to A is also A plus B. So from here, right, you know that OE is actually equivalent to OE is actually equivalent to OA plus AE. Right? So OE, right, is equals to A plus B plus with half A. Half A. Because this is AE, half A. Okay? So then, right, with that, right, you will be able to find OE already. OE is basically 3 over 2A. Let me wave it up. Okay, so OE, right, is equivalent to 3 over 2A, 3 over 2A plus B. Plus B. Okay, you know what I'm talking about, right? Use the wrong curve for baby thing. So plus B. So that's the OE. Okay, right? Now, next one, right, they want to find the position vector of D. So position vector of D, right, is just basically, right, talking about OD. Because position vector, I'm talking about OD. O to D. O to D. That's what I want to find. Okay, so what can we do is that I know OD, right, is just equivalent to OB, right, plus BD. But this is not, this is from C to B. So I need to use my this idea collinear, because CDB, right, they are in one straight line. Am I right? Right now. So what can I do is that, okay, I know that CD, right, CD is equals to lambda, okay, a lambda of CB. Can I do that? Okay, because they are collinear. Right, CD is equals to lambda of CB. Okay, and then CD, right, is equivalent to lambda of B. Because CB is B. So you got this. Right, that's CD. So this CD here now, right, okay, this I just put here like that for you to see. Right, from here, right, I know that this is just this part here, from C to D is B lambda B. From C to D, is it not able to draw? Okay, this is, draw one from here. Okay, from C to D, right, it's equivalent to lambda B. This is lambda B. Lambda B. So I'm going to write it as lambda B. That's the part here. Okay, and that makes this one, right, this part here, if there's the lambda B, right, lambda B, this part here will be 1 minus. Why 1 minus? Because the total is 1. So this is already lambda. So here, right, will be 1 minus lambda. So 1 minus lambda B. So 1 minus lambda B. Lambda B. Okay, this is like that. Okay? Right? So what can we do from here? Right? So then, right, what happened is that, okay, you know that OE, right, and ED also parallel. You know, it's a collinear. So from here, right, we know that OE can also be related to ED by constant K. I don't know what's my constant K lah. I just give it like that. So it's ED like this, right? But OE can find OE, right, is just OA plus AE. So OE is just OA plus AE, which is equals to K of ED. So what's ED? E to D, right, is EC plus CD. So EC, right, is 1 over 2A. Okay, I'll write that here first. Is equals to EC plus CD. Okay, because OE K equals to KD, ED, right, is just because they are collinear. right? They're collinear, they're in one straight line. Okay, if you don't want to use that, also you can use other one, but I think this is easy, right? So O to A is A plus B. So I'm going to write A plus B only. I don't want to write the baby thing. Okay, A plus B plus AE. A to E is half A equals to K bracket EC, E to C is half A plus with C to D lambda B. So it will give you lambda B here. Okay, because left and right is the same, so I'm going to simplify this part first. A plus 1 over 2A, I get 3 over 2A plus B. Okay, equals to, here I expand, I get 1 over 2K, Ka, plus 1 K lambda B. Okay, so what happened now is that I can compare the A with the A. I compare A with the A. So from here, right, okay, from here, I know that, okay, 3 over 2A is equals to 1 over 2K, Ka. So from here, right, I know that 3 over 2A is actually equals to 1 over 2Ka. I compare. So the A and the A can cut off. So from here, I know K equals to 3. That's the first thing. The K equals to 3. Okay. The second thing I know is that, right, I compare B with B. So here, right, I can say that B is equals to K lambda B. But B and B is the same. So I cut off the B and the B. So this is 1 lah. Because I cut off, it's going to be 1. There's a 1 here. But K, right, is 3. K is 3. So lambda, right, is actually equals to 1 over 3. Lambda is equals to 1 over 3. That's the value you get. You compare A with A, B with B. B with B. Then you just get the number out. You have the lambda and the K already. So now you want to find OD. You want to find O to D. So O to D, right? O to D is equals to OB plus with BD. Right? So OD is equals to O to B is 2A plus 2B. Then you minus 1 minus because it's opposite the direction of 1 minus lambda just now is 1 over 3. Okay, B. Right? You're going backward, so that's why it's negative. 1 minus lambda is 1 over 3 you get just now. Okay, so that's why OD is equivalent to 2A plus 2B minus, this is 4 over 3. No, this is 2 over 3. 2 over 3B. That's why your OD is equals to 2A. This is 2 minus 2 over 3. You get 4 over 3. So it's plus with 4 over 3B. 4 over 3. So that's the answer for OD. The position vector of OD. It's a bit tough, this question, because it is a killer question in this paper. You want to see whether students understand the idea. Okay, a lot of steps. Okay, alright, so that's the question. Okay, this is for you.